All right, this is Memory Section A lecture. Our prioritized standards are 6B and 6D. Objectively, we're going to discriminate between the stages of the information processing three-stage memory model. Memory is an active system receiving information from the senses, organizes and alters that information as stored, and then retrieves the information from storage. Now, the processes of memory serve three tasks: encoding, storage, and retrieval. By encoding, this is the set of mental operations that people perform on sensory information to convert that information into a form that is usable in the brain's storage system. So the information that can be encoded is pretty much any of your senses. Visually, it's probably a picture in your mind. Acoustically, it's a sound in your mind. Semantically, it's a meaning in your mind. Next process is storage. This is holding on to information for some period of time. Depending on what type of memory it is, it'll be longer or shorter. And the last stage is retrieval, which is getting information that is in storage into a form that can be used. So a properly encoded memory takes only a split second for a good cue to actually access that information, bring it into your consciousness, and possibly influence your behavior at an unconscious level also. Now, the information processing model of memory, which was developed by Richard Atkinson and Richard Shifrin, is a cognitive understanding of memory that emphasizes how information is changed when it is encoded, stored, and retrieved. So this model actually assumes that the processing of information for memory storage is similar to the way a computer would actually process memory in that system. Now, there are three sequential stages involved in forming memories. The first of those is sensory memory, and then you have working memory, and finally, long-term memory. So the stages basically work like an assembly line to convert a flow of incoming stimuli into meaningful patterns that can then be stored and later remembered. But again, this is the process. You start with sensory, go on to working, then ideally you have long-term memory. Now, these stages are categorized by varying capacities of stored information and varying durations of time that information can actually last in these different types of memory. Now, the first stage of memory is sensory memory, or SM for short, which is the point at which information enters the nervous system through the sensory systems. So sensory information is stored in sensory memory just long enough to be transferred to working memory. Now, sensory memory actually has a capacity to allow people to retain impressions for all sensory information after the original stimulus has actually ceased. Now, while sensory memory has a very large capacity, it typically holds sensory impressions, so that would be like the sights, sounds, smells, tastes, and textures that we experience, for only the duration of between a fraction of a second to only a few seconds. So sensory memory is a very, very short type of memory. It doesn't last very long. So for instance, an experiment. So we see these letters, and how many of those letters do you actually recall? So generally speaking, you probably only will recall a few of those letters, potentially maybe the first few, but basically all of these is highly unlikely you're going to remember those very long, because that's just the nature of sensory memory. So you can see it for a short time, then you're going to have a hard time remembering what you've seen. Now, there is sensory memory that's associated with all of the senses, including iconic memory, which is visual stimulation that forms a picture in the mind, and echoic memory, which is auditory stimulation, forming a brief memory of something they just heard. So that's going to have the duration of about 2 to 4 seconds. Now, iconic memory, this might be an example. So like when a child is making an image with a sparkler by spinning it very quickly, there's actually a light trail that kind of follows it. So that's kind of what sensory memory is. It's just very briefly. It's actually still seeing that even after that actual stimulus has went away. This information is then pushed out very quickly and then replaced by new information in a process known as masking. Now, additionally, tactile senses or memory is associated with taste. Olfactory is going to be associated with smell. Gustatory is going to be associated with taste. So there's going to be different types of memory for essentially every type of sense that we have. Now, the biological basis of sensory memory are the sensory pathways, where sensory memory consists of rapidly fading traces of stimulation in our sensory systems. Now, working memory must read these fading traces and quickly decide which information it needs to focus on and which it needs to ignore and allow to disappear. Now, the second stage of memory is called working memory, or WM for short, which preserves recently perceived events or experiences for less than a minute without rehearsal. Now, the term working memory is often actually going to be interchangeable with the term short-term memory. But short-term memory actually just kind of implies that you have information that's stored for a short period of time, which does describe working memory at some level. As where working memory, this kind of implies that information is actually retained in order to be later manipulated. So it's very related to it, but it also kind of involves that you're transferring it possibly into another form that you can actually use later to be manipulated. Now, working memory is where people access all conscious experiences. So if there is something you're actively aware that is happening, that is something that is in working memory. Now, working memory has a capacity of about 7 items, plus or minus about 2 items. So 7 is kind of the magic number. So anything beyond that is kind of beyond the capabilities of your working memory. Now, working memory also has a duration of between 15 to 30 seconds. So you're going to be able to keep this information in comparison to sensory memory a lot longer, but it's not an insane amount of time either. It's not even a minute long. Now, working memory having the most limited capacity of all stages of memory, and with a limited duration, can also make it difficult to process and remember large amounts of information. So like when you're hearing a lecture, possibly you're reading a book, it's not a long time, so it's entirely possible that you will forget a good amount of that. Now, the structure and function of working memory is marked by 3 important components: the central executive, the phonological loop, and the sketchpad. Now, the central executive, this directs attention to material that's retrieved from long-term memory or to important input from sensory memory. The phonical loop, this temporarily stores sounds, which helps you remember the mental echo of a stimulus. And then we have the sketchpad, which is used to store and manipulate visual images. Now, the problem of capacity and duration associated with working memory can actually be improved through what's called chunking and rehearsal. Now, the capacity of working memory can be increased with chunking, which is putting bits of information into meaningful units or chunks. So for instance, if we have this kind of larger number, that can be kind of a difficult one to remember unless we chunk it in some way. So if you put some hyphens into that, it's going to make this particular phone number easier to remember: 678-999-8212. Now, the duration of working memory can also be lengthened through maintenance rehearsal, which is saying bits of information to be remembered repeatedly in one's head in order to maintain it in working memory. So this would be like if you're given a number and you're like, hey, don't forget this number, 648, 648, 648, 648. And you just kind of repeat it over and over again so that you'll be able to remember the number 648 so that you can actually use it. Now, maintenance rehearsal is actually not overly efficient way of transferring information to long-term memory. So if you want to remember something potentially permanently, maintenance rehearsal is not actually the best way to do that. We'll actually talk about a better way to do that in later notes. So the maintenance rehearsal, this kind of explains why cramming for a test using just kind of simple repetition probably won't result in you remembering much of that material. Possibly you could do okay on the test, but if you want to remember that information a couple weeks later, just maintenance rehearsal is not very effective at doing that. Now, the biological basis of working memory involves the hippocampus and the frontal lobes. Now, the third stage of memory is long-term memory, or LTM, which is the memory system into which all the information is placed to be kept more or less permanently. Now, long-term memory stores information in meaningful mental categories, has an unlimited storage capacity, and for an unlimited duration. So long-term memory uses its unlimited capacity to store all the experiences, all the events, the information, the emotions, the skills, the words, the categories, the rules and judgments that have been transferred from your working memory. Now, unless falling victim to a brain injury or some type of brain disease like dementia, as for instance, your long-term memory is potentially capable of storing information for a lifetime. Now, there are two parts of long-term memory that are distinguished by the sort of information that it holds. We can have procedural memory, which is a division of long-term memory that stores information for how things are done. So this includes memory for skills, procedures, habits, and condition responses. And you can also have declarative memory, which is a division of long-term memory that stores specific information such as facts and events, with this type of memory requiring some conscious mental effort. Now, procedural memory is essentially mental directions and includes emotional associations and simple conditioned reflexes that may or may not actually be in your conscious awareness. So when we talk about procedural memory, you just know it. You don't necessarily have to think about it to know these things. Now, you may be able to see evidence of declarative memory sometimes when you ask somebody a question and you see their eyes kind of roll to the back of their head because they're trying to retrieve that memory because you asked them a question that they actually have to consciously think about what the answer might be. Now, procedural memory is used to remember the how-to skills that we have previously learned. So potentially like tying your shoes, riding a bike, playing some type of musical instrument. Now, we are generally only conscious of procedures necessary to learn a skill during the early phases of acquiring a new skill. But after having thoroughly learned the procedures, we no longer consciously are going to be aware of that. So once you've learned how to walk, you don't have to concentrate on how to walk every time you want to walk somewhere. Or after you've learned how to throw a ball, you don't have to really think about how to throw a ball when you throw a ball in the future, or ride a bike, or tie your shoes, or do any of the other types of skills that we might have. Now, procedural memory also includes motor skills, which we've talked some about, operant conditioning, which is associating voluntary behavior and a consequence. So you do something, and then there's a positive or negative consequence to doing that. That's how we can learn things. And also classical conditioning, which is associating an involuntary response and a stimulus. So if there's a particular word your mom freaks out about, you pretty much figure out that, oh, well, I guess I shouldn't say that because mom might potentially freak out when that happens. As for instances of some of those. Now, while procedural memory involves skills we perform unconsciously, so potentially like after you've learned how to drive a car, like getting in a car and driving is not really something you have to really concentrate on all the specific details involved in driving a car. But declarative memory actually involves conscious awareness. So potentially you might know how to drive a car, which is procedural memory. But if you're trying to determine the best route to get to the Westtown Mall in Knoxville, you're probably going to need your declarative memory to think about what the best route to get there is possibly going to be. Now, there are actually two subdivisions of declarative memory, episodic memory and semantic memory. Episodic memory is a subdivision of declarative memory that stores memories for events or personal experiences or episodes in your life. Now, this type of memory stores temporal coding or time tags to identify when an event occurred, and context coding that indicates where it took place. Now, episodic memory acts as an autobiographical memory that is consulted when someone asks you a personal question. So if someone is like, hey, where did you grow up? This is going to be your episodic memory. Now, semantic memory, this is a subdivision of declarative memory that stores general information, including facts, language, and general knowledge concepts. So this type of memory usually is going to retain no information about the time or the place in which the contents were acquired. Semantic memory acts kind of like an encyclopedia or a database for information in your brain, keeping the names, the faces, grammar, history, music, manners, scientific principles, religious beliefs, just all of the information that you just know. So when people ask you a question for a class on a test, this is going to be your semantic memory. Now, many parts of the brain form the biological basis of long-term memory, with certain parts associated with creation of new memories and others associated with retrieval of old memories. Now, the hippocampus and the amygdala appear to be associated with the creation of new memories. How we know that is the case of patient HM, which in a botched surgery attempting to treat his severe epileptic seizures, actually, when he suffered as a young man, they actually had his hippocampus removed from both sides of his brain. After the surgery, HM didn't really have as many seizures, but the downside, they quickly figured out that he could still retrieve long-term memories that he had before the surgery, but he was not capable of actually forming any new long-term memories. So in the over 50 plus years since his surgery, HM couldn't recognize people who potentially had taken care of him for decades. He had no knowledge of major events that took place, couldn't remember anything about the moon landing, 9/11 attacks. He was also shocked whenever he would look in the mirror because he was expecting to see a young face. And when he was much older, he was not expecting to see an older face because he didn't remember all that time actually passing. He still thought of himself as a young person. Now, most long-term memories make an immediate stop in the hippocampus on their way to final long-term memory storage in the cerebral cortex, where they are changed into relatively permanent memories in a process that's called consolidation. Now, since HM no longer had a hippocampus, there was actually no way that he could ever consolidate a new memory into his long-term memory. So he could possibly remember something for maybe up to 30 seconds, which is kind of the capacity of long-term of your working memory. But to actually translate that into long-term memory, he didn't have that function of the brain anymore to actually do that. Now, the amygdala actually plays a role in strengthening memories that have strong emotional associations. So these emotional associations seem to aid in accessing and retrieving long-term memories. The amygdala is actually likely the culprit behind post-traumatic stress disorder, where the emotional relationship of certain memories are going to be so intense that it can be virtually debilitating when certain events trigger a memory of a traumatic event. And additionally, the brain uses some of the same circuits for memory that it uses for sensation, perception, and motor responses. For instance, some that have suffered injury to a part of the brain associated with sensations can actually cause memory loss for memories that are associated with that sense. Also, the general principle seems to be that memories of sensory experiences involve the same parts of the brain that were used to perceive those experiences in the first place. All right, that was Memory Section A lecture. Our prioritized standards were 6B and D. And objectively, now you can discriminate between the stages of the information processing three-stage memory model.